For centuries, the formidable Swiss Alps have stood as an unyielding barrier, their towering peaks and treacherous passes dictating the flow of trade and travel across Europe. Generations have gazed upon this natural fortress, dreaming of a swift, unhindered path through its heart. It was a dream of connection, of bypassing the arduous climbs and dangerous descents that defined the Gotthard Pass for millennia. This dream, however audacious, would one day coalesce into the most ambitious tunneling project in human history, challenging every known limit of engineering and human endurance. The 20th century saw the existing Gotthard Rail Tunnel, an engineering feat in its own right, struggling to meet the demands of an increasingly connected world. Its steep grades and winding paths limited speed and capacity. A radical solution was needed, not to conquer the mountains, but to bypass them entirely. The vision for the Gotthard Base Tunnel was born, a deep, flat, and direct line beneath the entire massif. This was not just about speed, it was about efficiency, environmental protection, and cementing Switzerland's role at the heart of European transport. The sheer scale of the Gotthard Base Tunnel project defied easy comprehension. It would become the longest and deepest railway tunnel ever built, carving a path through solid rock for nearly 57 kilometers, or 35.5 miles. At its deepest point, the tunnel would lie an astonishing 2,300 meters, or 7,500 feet, beneath the mountain peaks. This was more than just a tunnel, it was a subterranean highway, a critical artery for European commerce, designed to handle hundreds of trains daily, far beneath the world above. The undertaking was colossal. The primary adversary was the mountain itself. The Swiss Alps are composed largely of hard, abrasive granite, among the toughest rock on Earth. This wasn't a uniform, predictable canvas. Geologists anticipated complex fault zones, shifting rock formations, and pockets of intensely fractured material. Boring through such geology meant facing constant uncertainty and immense physical resistance. Every inch gained would be a battle, demanding tools and techniques capable of withstanding colossal forces and grinding through stone as hard as steel. As the tunnel plunged deeper into the earth, another formidable challenge emerged: extreme heat. The natural geothermal gradient meant that for every 100 meters of depth, the temperature increased. At 2,300 meters below the surface, rock temperatures could soar to 50 degrees Celsius, or 122 degrees Fahrenheit. For humans and machinery alike, this environment was an inferno. Managing this heat was not merely a matter of comfort, it was crucial for worker safety, equipment longevity, and maintaining efficiency in a 24-hour operation. To conquer such an immense distance and complex geology, a single-entry approach was insufficient. The strategy involved attacking the mountain from multiple fronts simultaneously. 5 access points were established along the tunnel's route, including 2 main portals and 3 intermediate access shafts that plunged vertically into the Alps. This allowed construction teams to excavate northbound and southbound from each point, effectively creating a sprawling underground factory with multiple synchronized operations. It was a logistical masterclass, orchestrating precision work deep within the earth. The heroes of this subterranean drama were the tunnel boring machines, or TBMs. For custom-built behemoths, each over 400 meters long, nearly half a kilometer, were deployed. Nicknamed worms by the crews, these machines were essentially mobile factories. Their rotating cutter heads, studded with tungsten carbide discs, gnawed through the granite, while conveyor belts removed excavated rock, and segments for the tunnel lining were installed immediately behind. They were precision instruments, engineered to devour rock at an astonishing rate, tirelessly pushing forward. While TBMs excelled in stable rock, certain sections of the tunnel, particularly through complex fault zones or areas requiring specific geometries, necessitated the traditional drill and blast method. Here, skilled miners drilled precise patterns of holes, packed them with explosives, and carefully detonated them to break the rock. This method offered greater flexibility and control in challenging geological conditions, allowing engineers to adapt to unforeseen changes in the rock structure. It was a testament to the versatility of the project that both cutting-edge and time-tested methods worked in harmony. The logistical challenge of supporting a construction site deep within a mountain was immense. Every piece of equipment, every worker, every cubic meter of concrete, and every meal had to be transported into and out of the tunnel. Simultaneously, millions of tons of excavated rock had to be removed. This required a sophisticated internal railway system, custom-designed ventilation shafts, and a constant flow of resources. It was a city built underground, operating with the precision of a Swiss watch, a relentless ballet of men and machines against the rock. To combat the scorching temperatures, an ingenious cooling system was devised. Chilled water, circulated through pipes embedded in the tunnel walls, absorbed the rock's heat. Massive ventilation systems constantly pushed fresh, cool air into the working areas, while exhaust fans drew out the hot, humid air. This intricate network of cooling and ventilation was vital, not only for the safety and productivity of the thousands of workers but also to prevent machinery from overheating and failing in such a hostile environment. It was an invisible infrastructure, yet utterly essential. With thousands of people working in such an extreme and unpredictable environment, safety was paramount. Rigorous protocols, constant training, and immediate access to emergency services were non-negotiable. Every worker underwent specialized alpine tunneling safety training. Escape tunnels, emergency stations, and rescue trains were integrated into the tunnel's design from the outset, ensuring that help was always within reach. The commitment to safeguarding human life amidst the immense risks was a defining characteristic of the project's success, a testament to its responsible execution. Beyond the machines and the concrete, the true driving force of the Gotthard Base Tunnel was its diverse workforce. Thousands of engineers, geologists, miners, and support staff, hailing from dozens of nations, dedicated nearly 2 decades of their lives to this endeavor. They faced isolation, long shifts, and the inherent dangers of working deep underground, far from daylight. Their resilience, ingenuity, and unwavering commitment forged not just a tunnel, but a community bound by a shared, monumental goal. Their sweat and spirit are etched into every kilometer of this incredible passage. Despite meticulous geological surveys, the mountain always held surprises. Engineers encountered unexpected water ingress, rock bursts from immense pressure, and sudden shifts in geological composition. Each unforeseen challenge demanded rapid problem-solving, adaptive engineering, and fearless improvisation. Instead of halting progress, these obstacles became crucibles for innovation. Teams developed new ground stabilization techniques, adjusted boring strategies on the fly, and reinforced sections with unprecedented speed, transforming every setback into a learning opportunity. On October 15, 2010, after 11 years of relentless tunneling, a momentous event occurred. The final few meters of rock separating the northbound tubes at Fido were ceremoniously blasted away. Shears erupted as light streamed through from the other side, signaling the main breakthrough. This was more than just a hole through a mountain, it was a symbolic victory, the physical manifestation of years of toil and ingenious engineering. The two halves of the tunnel, bored from opposite directions, met with incredible precision, a testament to the meticulous planning and execution. The breakthrough marked a major milestone, but the work was far from over. The following years were dedicated to fitting out the vast underground space. This involved installing 290 kilometers of track, over 100,000 tons of cables, ventilation systems, cooling infrastructure, and advanced signaling technology. The tunnel transformed from a raw rock cavity into a sophisticated, high-speed railway artery. Every component, from the smallest bolt to the largest substation, was installed with precision, ensuring the tunnel could meet its operational demands safely and efficiently. On June 1, 2016, after 17 years of construction, the Gotthard Base Tunnel was officially opened to the world. Dignitaries from across Europe gathered to witness a moment of profound significance. It was a celebration of Swiss ingenuity, European cooperation, and the indomitable human spirit. The first passenger trains glided smoothly through the heart of the Alps, completing a journey that once took hours in mere minutes. The long-held dream of a direct, flat route was finally a reality, a testament to the patience and perseverance of all involved. The impact of the Gotthard Base Tunnel extends far beyond reduced travel times. It has fundamentally reshaped transalpine transport. Freight trains now move goods more efficiently and with lower emissions, shifting volume from roads to rails, contributing significantly to environmental protection. Passengers enjoy faster, more comfortable journeys, connecting regions like never before. The GBT stands as a permanent monument to what is achievable when ambition meets innovation and relentless dedication. It is a symbol of engineering triumph, a marvel for the ages. The Gotthard Base Tunnel, an odyssey spanning 17 years, is a story not of disasters, but of resilience. It is a testament to meticulous planning, courageous execution, and the unwavering belief in a vision. The challenges were immense, boring through ancient granite, enduring scorching heat, and managing unprecedented scale. Yet, at every turn, human ingenuity found a way. This tunnel is more than just concrete and steel, it's a profound declaration that with enough will, and enough brilliance, humanity can sculpt even the most formidable natural barriers into pathways for progress. A true engineering marvel, enduring.